So here I'm explaining the second problem. An IC engine uses 6 kg of fuel having a calorific value 44,000 kilojoule per kg in 1 hour. The power indicated power developed is 18 kilowatt. The temperature of 11.5 kg of cooling water was found to rise through 25 degrees centigrade per minute. The temperature of 4.2 kg of exhaust gas with specific heat 1 kilojoule per kg Kelvin was found to rise through 220 degrees centigrade per minute. Construct heat balance sheet for the engine. So in this problem, they are given an IC engine uses 6 kg of fuel. So means mass of fuel they are given 6 kg of fuel per hour. So means 1 hour. So 6 kg per hour. So that is 6 kg divided by 60. So converting from kg per hour to kg per minute. So you get 0.1 kg per minute. CV calorific value 44,000 kilojoule per kg. So that is CV is equals to 44,000 kilojoule per kg. The indicated power developed is 18 kilowatt. IP is equals to 18 kilowatt. That is 18 kilowatt can be written in terms of kilojoule per second. So that is 18 into 60, 1080 kilojoule per minute. The temperature of 11.5 kg of cooling water. So means mass of water is MW is equals to 11.5 kg was found to rise through 25 degrees centigrade per minute. So means was found to rise. Rise means they are given directly the water inlet temperature and outlet temperature. So that is TW out minus TW in is equals to 25 degrees centigrade. The temperature of 4.2 kg of exhaust gas. So means mass of gas mg is equals to 4.2 kg per minute was found to rise with specific heat 1 kilojoule per kg Kelvin. So that is CPG they have given. Specific heat of exhaust gas Cp exhaust is equals to 1 kilojoule per kg Kelvin was found to rise through 220 degrees centigrade per minute. Means is exhaust gas temperature minus room temperature is equals to 220 degrees centigrade. So these are the data they given. By using this data, we have to create a heat balance sheet. So they are not specified either in kilojoule per minute or kilojoule per second or kilojoule per hour, but in the problem they have given directly in mass of water in kg per minute and mass of gas they have given kg per minute. So based on that conclusions, we have to prepare the heat balance sheet in kilojoule per minute basis. Now step 2 is to construct heat balance sheet on minute basis. So what are the parameters we have to calculate? So if you see the heat balance sheet, in first one is heat supplied by fuel. So MF into CV. So what is heat supplied by fuel? So that is MF into CV. So CV mass of fuel is 0.1 into 44,000. If you multiply both the values, you'll get 44,000 kilojoule per minute. Next one is B in the heat expenditures. So what we have to calculate in the second problem with the available data, we can calculate. One is brake power. They are not given. So here there is no calculation of heat loss per BP. Directly we need to calculate heat loss per FP. So before that, here they are given heat indicated power value they are given. Heat loss per IP is equals to 18 kilowatt. So means kilowatt can be expressed in terms of kilojoule per second. 18 kilojoule per second. Multiply for this 18 into 60. So then we are getting in terms of kilojoule per minute. So that is 18 into 60. If you multiply, you'll get 1080 kilojoule per minute. After that, not here they go due to unavailable data, heat loss to BP and friction is not calculated. It is under unaccounted heat losses. Why means here what they are saying in the note. So there is no data of BP. So means to calculate the friction power, we have the formula indicate power minus brake power. So here brake power is the data is unavailable. So based on that, friction power is equals to indicated power. So friction power is equals to indicated power means whatever the indicated power value we have, same thing it is heat loss to friction power is equals to 1080 kilojoule per minute. So next we can calculate heat loss to cooling water. That is QW is equals to MW into CPW, TW out minus TW in. So this is a formula. So here CPW they are not specified. It is a standard value, 4.187 kilojoule per kg Kelvin should be assumed. So mass of water they are given 11.5 kg per minute into substitute specific heat of water and TW out minus TW in they are given 25. Substitute all the values and calculate. We get 1203.76 kilojoule per minute. Directly here the mass it is kg. Here CP it is unit is kilojoule per kg Kelvin. Temperature unit is Celsius, but it is in degrees Celsius. Kg it will be gets cancelled. Kelvin should be gets cancelled. What is the remaining? It is kilojoule per minute. So QW it is in terms of kilojoule per minute. So after finding the next we have to calculate heat loss to exhaust gases, that is MW into mg into cpg into T exhaust gas minus TR room temperature. So here they are given what is the mass of gas 4.2 into specific heat of exhaust gas is 1 kilojoule per kg into, so what is the T exhaust temperature is difference they are given, exhaust minus room temperature difference they are given directly 220. After substituting all the values we'll get 924. So after calculating all the parameters, next I have to draw the heat balance sheet. So first draw the table, heat input, draw the table, heat input kilojoule per minute. So then heat expenditures. So now here heat input is heat supplied by fuel. So that is how much we got the value MF into CV. That one I have to write down here 4400. So same thing you can write one more time 4400. So then after that heat expenditures. So heat loss for IP. First one is how much the value have got. I have to write down here 1040. Next heat loss to cooling water 1203.76. Third one is heat loss to exhaust gas, that is 924. After this unaccounted heat equals A means heat supplied minus the addition of first, second and third expenditures, that is heat loss per FP, heat loss to cooling water plus heat loss to exhaust gas. So the total heat supplied minus the summation of these three factors, it will give unaccounted heat. So after finding the unaccounted heat, I make it add the total of the heat expenditures. So how much will get 4400. So the heat supplied total it should be equal to the heat expenditures total. So both the values when it should be gets equal. So your heat balance sheet is balanced. So this is about the second problem. So here I'm winding up the session. Thank you.